Imagine a customer is trying to pay 4999 for a subscription. They have the money. They want the product. They have already reached the payment page. But the payment fails. Maybe the acquiring bank timeout. Maybe the card temporarily declined. Maybe a e-mandate expired. Maybe the customer simply closed the checkout page. From the merchant's perspective, the result looks almost identical. 4999 was expected, but 4999 never arrived. And this is where we identified the problem. Most payment infrastructure is extremely good at telling merchants that a payment failed. But knowing that a payment failed is not the same thing as knowing what to do next. Should we retry? Should we wait? Should we send the customer a payment link? Should we ask them to update their payment method? Should we stop completely? Or should a human review the case? That's the problem we decided to solve with RecoverIQ. Today, merchants typically fall into two extremes. The first is blind automation. A payment fails and the system retries it 2 or 3 times. But imagine the customer's card has insufficient balance. Retrying immediately doesn't solve anything. Or imagine the bank is temporarily unavailable. Retrying at exactly the same moment can make the situation worse. The second extreme is manual operation. Finance or operation teams receive failed payment reports, export spreadsheets, contact customers, track promises, follow up on invoices, and manually decide what should happen next. That doesn't scale either. So we should ask a simple question. What if the payment recovery could be treated as an intelligent decision-making problem? That's what RecoverIQ does. So RecoverIQ is basically an autonomous revenue recovery operating system. And I want to explain what we mean by that because this isn't simply an analytics dashboard. RecoverIQ sits around the merchant's payment events. When an event comes in, we first understand what happened. Then we classify the revenue leak. Then an intelligence layer determines the appropriate recovery strategy. But we don't allow AI to directly execute financial actions. The recommendation goes through deterministic merchant policies. Only if the policy allows that action do we execute the recovery. And after execution, we record the entire life cycle in an audit trail. So the complete loop basically starts from the detection, then the diagnosis, then the decide layer, then the guardrails, then the recover, and then the verification. So as you can see here, this is the deployed version of our application, which is deployed on Netlify on front end, and the back end is basically on render. So as you can see here, this is the dashboard, and we are also using Docker and Kafka for integration, and I will explain you why are we using them. So let's say from a merchant's perspective, imagine that I am a CFO or head of revenue operation. I don't want to look at individual payment IDs first. My first question should be how much money is currently at risk, and that's why we built the revenue command center. And this is the revenue risk. So this is 4 cards. These are actually the cards which are actually useful for me as a CFO. So not every failed payment is recoverable. So if a customer has cancelled a subscription intentionally, we shouldn't pretend that money is recoverable. If a card is permanently invalid, that repeatedly retrying doesn't magically create a revenue. So we calculate something which is known as ERV, or we can say its expected recovery value. So that's what our estimate is. So as you can see here, this is the ERV part, and this is calculated by AI score engine, and that's our estimate of a portion at risk revenue that has realistic probability of being recovered based on the available transaction and the customer context. So a Gemini API has been integrated in the backend, and we have integrated free Gemini API, and we have used an array of Gemini APIs so that if we continuously add a scheduler which runs every 5 minutes, and based on their health, we actually give to the best model first, and the fallbacks are basically the models which can be run behind the scene. So then point out to this recovered revenue. So what is this? So this is where the dashboard moves from prediction to business outcome. So we are no longer talking about a failed transaction. We are actually talking about the money that actually come back through the recovery process. And then finally, this recovery rate thing. Now, what is this recovery rate? This tells us that the merchant how effective the recovery system is. So what are this recovery conversion funnel? So this funnel is really important feature because it explains that how the recovery or the revenue which is moved through our system. So not every event should become an AI decision, and not every AI decision should become an intervention. And not only every intervention will result into customer actually paying. So this is the webhook injection. As you can see here, the webhook injection is been shown, and this is the first part which is webhook injection. Then this is where the raw event entering the RecoverIQ. Then the second part basically stands for AI qualified and scored. What does this mean is we are determining whether this event represents meaningful recoverable revenue and what the likely cause is. Then the third one is intervention dispatch. We are actually decided that some recovery action should happen. Then the fourth one is customer engage. The customer has received the relevant recovery mechanism. And finally, there is a revenue cash settle, which is the outcome we are ultimately optimizing for. So we are aiming for this funnel. Basically, the main aim behind building this funnel feature is that to look the revenue which is being lost inside the recovery lifecycle. Okay, so we move on to the next feature, which is the recovery experiment. Now, what does this do? This is a 1,000 event experiment. So I would like to tell you that this AI is better. We want answer a fundamental question: does intelligence actually improve recovery, or are we just building another dashboard with impressive numbers? So we built an experiment. So we are following three strategies. First strategy is basically doing nothing. This is the baseline strategy by doing nothing. So because what happens is sometimes the failed transaction naturally recover later without any intervention, and this tells us how much revenue would have been actually recovered anyway. So this is the first part, and we have generated some numbers, and these numbers are the real numbers which are being actually implemented. Then the second strategy is now retries. So the second strategy represents a traditional approach. Our payment fails, retry it. If it fails again, we try again. We want to establish how much recovery we can get from simply increasing the number of attempts. But this approach is a problem. It treats fundamentally different failures as if they are the same. A temporary bank timeout and an insufficient balance decline are not the same problem. Yet a blind relay strategy could not be useful. So there is customer churn which comes into picture here. But still we have actually implemented an average value of all of this which comes out to be 4.29 lakh. The third strategy is our application, that is RecoverIQ. Now this time we actually run RecoverIQ on the exact same code, and the system here doesn't simply retry everything. It first asks, why did this payment fail? Is this failure recoverable? And the agentic AI layer has been integrated for the same. What intervention has the highest probability of success? And is this intervention allowed according to the merchant's policy which has been written in our application.yaml? And only then it acts. Then it reveals numbers, and as you can see here, the results, it is actually 4x than the normal no intervention and 2x times actually retry mechanism. So what does this say? The purpose of this experiment is to demonstrate that the RecoverIQ isn't simply automating retries. We are changing the decision making layer around the failed revenue. So the third part is the revenue at risk part. So I would like to answer the simple question: where exactly is revenue leaking? Because payment failure is only one type of revenue leakage. So payment failures is just a part of this revenue leakage. There can be other possibilities as well, such as subscription mandate. So here we have traditional payment failures, card declines, UPI issues, bank timeouts, as well as similar events. These are generally the most obvious leaks because the payment attempt actually happened. So the subscription mandates, as you can see here, these are the actually real data which is fetched from this thing, and ERV, expected recovery value, these have been actually calculated. Then the guardrails which are been verified, and you can actually view the customer profile here as well. You can execute any action, and it will automatically get executed. As you can see, recovery action is recovered. So you can also view the customer profile here, and this is the feature which we have actually integrated. So you can open any customer record here, Harshvardhan. We have actually recovered its record, and other than that, we can auto recover high probability things. Currently, you can see here probability scores are being given here, and as you can see here, if you auto recover, if there is 80 or more than 80% recoverable probability, we'll actually hit this button, and we don't need to manually trigger each and everything. So this is just add on this feature so that you could actually do this thing and execute recovery action. So this can be also done here for the same. So recovery action executed for Rajvardhan. So we are actually targeting a particular customer first, and then as we successfully keep on executing this, it will automatically get triggered again and again. Okay, so this is one thing. So check out abandonment. So no payment get technically failed, the customer simply didn't complete it, but from a revenue perspective, we still have a high intent customer who disappeared before the transaction was completed. So that is one thing. The another thing is B2B receivables. So B2B receivables is what the payment infrastructure may work perfectly. Okay. But the problem is that the invoice is overdue, so this requires a completely different recovery strategy. This is why Recovery IQ isn't a smart retire product. We are trying to build a common recovery layer across multiple forms of revenue leakage. The fourth feature which I am going to point on is the recovery queue. This is the recovery queue which is actually implemented. So now we are going to identify the case that we actually require action. So this is the operational recovery queue. And notice that what we are showing here, we are not simply showing payment failed. What we are going the operational context. So we are actually telling who is our customer, how much money is at risk, what caused the failure, what does Recover IQ recommend, and importantly, is that action allowed under the merchant's policy. So you can see this recommended action thing. This is not hardcode. This is actually being given by the agentic AI layer. It actually goes through a 12-layer transformer architecture, and based upon those actions, it will actually give you the recommendation based upon those all the neurons that are actually triggered. And at this moment, you can see some critical events. There are more critical events. Some are high valued events. So these all events need to be taken into care about. Then there are medium and low events as well, but it is prioritized based upon the critical ones first, so that we get maximum attention on critical events first. Then we actually get a C. Recover IQ has already evaluated it, so they come our recovered state. Okay, right? Then we also get the important transition that we are moving from an analytical state into an operational state, right? And why is this queue important, the recovery queue? So we intentionally support both autonomous and human in the loop workflows. So we can also run a simulation here, and uh, it will actually run a simulation at once, and it will also show you how much revenue has been recovered. And obviously currently in our database, the number of users that were before the demonstration of this video and now is the same. So the revenue recovered is same as the previous run simulation part. But as it will be actually used by our audience, this number is will actually been fetched from the DB. So as you can see, this is the database full of our customers and payments history. So all the transactions, all the payment attempts, retries, everything will be stored here, and all even successful will be stored here. Although they are not of our use case, but still we are storing it as the option. So these all are the, you can execute any of them. So I will just execute it for any customer and it will always get recovered. Next is the payments part. So what happens is that currently you can see the payment recovery. So what smart retries is really important in this case. So when does another attempt actually make sense? We maintain a bounded retry timeline. So this will actually, we don't retry forever. We don't keep hitting the payment gateway indefinitely. We don't keep treat every failure as retriable. So, for example, if a system determines that a failure is temporary, we can schedule a later attempt instead of immediately repeating the same field again. So, this is one of the thing. So, you have a backoff, exponential backoff thing. So, that is somewhat similar to what we are actually implementing here. And this stop condition is extremely important because automation without boundaries is dangerous in financial situation. And in this infrastructure, it is even not allowed due to some compliance policies. So once the retry policy has been exhausted, Recover IQ actually stops. That prevents an agent from continuously attempting transactions simply because it thinks another attempt might work. So the intelligence isn't just knowing when to act, it's also knowing when to stop. So the another module which I have integrated here is a subscription module. This is a subscription module, and look at different problem which we actually discussed up till now. So imagine this customer has been paying us every month for a year and suddenly the recurring payment fails. This isn't really a customer acquisition problem. It's involuntary churn. So if we simply retry the same failed mandate repeatedly, you are not necessarily fixing the underlying problem. So RecoverIQ can move the customer towards an alternate payment flow. So the idea is to reduce the amount of friction between payment failure, customer action, and the successful payment. So from a merchant perspective, recovering a one payment is useful, but recovering a customer's future payment is even more valuable. So these are all the details which you actually get here. Then the checkout recovery. So checkout recovery is basically the customer reached checkout, they showed the purchase intent, but they left. So it's basically capture the churn rate which we are discussing up till now. So traditional payment monitoring doesn't necessarily treat this as a payment failure, but the Recover IQ treats it as a revenue recovery opportunity, right? because we want customers to actually invest the transactions with us as much as they can. So this is important because we are moving from payment failure recovery to the recovery intent recovery. Then the receivables, and to be specific, it's B2B receivables, and an invoice that's 2 days overdue shouldn't necessarily receive the same treatment as one that's 45 days overdue. So Recover IQ can use this information to determine the appropriate follow-up workflow and bring payment collection into the same recovery system. So you can see here all the details are being fetched here. So if you want to see the B2B receipts, you can just open this tab and you can get the main part, the AI decision layer. So now we have shown what actually happens operationally. So let me show you intelligence behind those decisions. So this is something which we need to check in detail. So first we ask the model to understand the event. So the event is captured to Kafka, consumer, brokers, and all that thing. And after that we capture the event, we ask it, is this likely a temporary bank network problem? Then is it due to insufficient fund? Is it a mandate problem? Or is it something where we should simply stop? So then we actually ask using it to give confidence score. So that confidence score is the, we don't say AI to directly retry. We want them to understand what the system believes happened and how certain it is. So, but here is a most important architectural decision. AI does not get the final authority to execute the financial action. The AI recommends, the policy engine decides whether that recommendation is permitted or not. So there is something which is retry limit thing. You can see here, you can execute it, and once I executing, it will get executing. Okay. You can see max limit retry. This is the retry limit. So you can give 3 limit retry cup. Then the customer consent is necessary and the amount limit. So these are the 3 things which you are actually simulating here. It takes a bit of time. We can even reject it directly. It's rejected. Rejection will be faster, and these are deterministic rules. That means a model cannot simply hallucinate its way to execute a transaction. And basically, we are not really focusing on one AI model. We are using MOE, which is mixture of experts, so that we come up with a better decision and we maintain a higher accuracy than the one which can be interpreted by single agent. And then I would like to go through the customers. These are all the customers that are actually using our application, or maybe whose our revenues are at risk. We are actually capturing them at this screen. We can add a new customer. We can perform all the crude operations. Then I'll not waste time telling you about customers, but go to the analytics part. This is the analytics part, which every promise to pay, which is one of the things which we need to understand. So promise to pay is one of the important things. This analytics part is basically used by the HRs or the ones which are handling the financial operations. So this tells you about the revenue at risk over time. Then it tells about recovered revenue over time. Then recovery by channels, you all the channels, and we'll go to promise to pay section. I'll show you why these are important. Campaigns, recovery campaigns. So these are the campaigns which and along with the payment ID. So communication basically is all the communication that are been transmitted between the AI agent and the customers. So these have been tracked here. And I logged in earlier using Club to save the time. So I have logged in with my credential with the revenue operation thing. Okay. So we go to promise to pay section now in detail. So here is the example. Suppose a client tells us I'll pay on Friday, and a dumb reminder system will continue sending messages every day. That's a terrible customer experience, right? So what does RecoverIQ records? It will record that promise, and it will, while the promise is active, the system can pause unnecessary reminder. And if the Friday passes and payment hasn't happened, then the promise will actually trigger and the recovery workflow can escalate. So the objective isn't to maximize the number of messages we send, it is to maximize the recovered revenue without damaging the customer relationship. So this is what the promise to pay is, and this broken promise actually mean. We can simulate the broken promise, we can break the promise, and that's the thing. Audit trail. Now this is one of the important parts as well. I'll just show you one of the audit trail. As you can see here, event details have been captured. So imagine a financial team asks, why did RecoverIQ retry this payment? We need to answer that question, right? So we can trace this case from the original failure, then the AI evaluation, then the recommendation, then the policy evaluation, as you can see on the my right hand side of the screen, and the policy which have been actually implemented, the recovered action, and then the final outcome. So these all things can be tracked. So every important decision has a history. So this is critical because autonomous financial system cannot be black boxes. They need to be audited. And while auditing, we need every proof case. Why are we actually using this? So to handle this, we have actually implemented event details for every action that we are actually performing. Then we have the policy center. Always see here, all the merchant has to do is policy define the boundaries within which RecoverIQ is allowed to operate. So as you can see, the invoice, the retry limit, all the things are being written here, and the Razorpay integration, one of the core part. This is the Razorpay integration page, wherein we everything we have shown far will be meaningless if we couldn't connect to actual payment infrastructure. So that's why we built the integration layer around Razorpay. So RecoverIQ receives payment events through webhooks, and we verify the webhook signature so that we cannot blindly trust incoming requests. So we create a recovery decision engine and then apply policies, and then we execute a permitted recovery action through the payment infrastructure. So this is what the integration actually means. We can run the simulation. I have shown you this earlier, and this is the thing, right? This is the settings page, normal settings page. We can actually configure what we want as per our needs. So this is the entire application. We can get an instant Razorpay link from. We can export it here. We can create and send. This is the actual Razorpay link, and we can actually perform payment. So this is the target customer, and we can choose any customer we want, and we can actually create an SMS trigger link, and we can send it as well. So we created it. You can create and send it. So we generated it, sent via email. So we have the email track, so we can send it via email. So to summarize this, I have created a small PPT which I would like to finish off, so that I could actually don't miss out any point. So I'll slow down here and bring everything together. So the problem we started was simple. We started with the problem which was a failed payment doesn't necessarily mean lost revenue. But today merchants often don't have an intelligent system deciding what should happen next. So RecoverIQ closes that gap. We take the event from the payment infrastructure. We understand what happened. Then what we do is we actually classify the revenue leak. We use AI to reason why the recovery opportunity is used. We apply deterministic merchant policies. We execute the appropriate bounded action. We observe the result and we record the entire decision trail. So this is a technical architecture. I have explained it on the top of it. We have integrated some webhooks. We have these layers which are the AI decision layer, ingestion layer. Then some policies that are governed, which are actually the compliance rules. Then we have actually deployed this. So there are MongoDB Atlas into action, Netlify, Cloud, and the email gateways, all the APIs, WhatsApp APIs, email APIs, and we also have retry mechanism, which is technical outcomes that you can see of our application. So this was just an overview to save time. Then this is the mathematical scoring engine what we have actually used, the base score, the payment history, and this is just how are we calculating ERV, which I have missed so far. The ERV calculation has been showed on the screen. Then the policy guardrails, which is the fifth layer. If you remember, I have started with that only. These are the policy guardrails which we actually inculcate in our application. Then the benchmark proof, I have shown you this on the landing page. If you want to see it again, this is the proof, right? And then we just show you about the Razorpay architecture, which is using the API only, but to integrate it was not a easy task. I had to face some technical difficulties, like to integrate Razorpay integration, we need to have your key and the password. So that is the first primary thing. Then clerk authentication. You don't get this APIs easily. You have to search for it. Also, Spring Boot was something new to me. I have integrated Spring Boot in the backend, and the front end is React. So this is B2B receivable, D2C checkout drop off, and all these things. And we also support English conversation AI at the customer point of view and multi-channel recovery. So Kafka events and brokers are being used so that we can recover the events as well. And operational governance, competitive advantage and vision. So the next steps which we are actually planning is going into a real production environment where actual users can simulate our application, and we could get the exact result as we have actually discussed so far, so that this could be useful within the application to millions of people, right? So that's it from my side. Thank you so much, and have a nice day.